Today I'm going to solve this triple integral. So first of all, we need to, they say determine the value of the integral here, right? It's just to determine it, and then what? Where W, we've got this one, is what? Is the solid region bounded by the plane C equals to 12 and the paraboloid Z blah blah blah. Okay, let's try to sketch this solid region. Here it's Y, here we've got it Z or Z, same thing. Oof. Here it's X, right? Okay, they say what? We have Z it's equal to, it's 12, Z it's equal to 2x plus this minus 6, right? Okay, if we see, we let zx equal to 0 and y equal to 0, we've got minus 6, so it's around here, right? And 8 minus 6 here. Okay, it is minus this 6 here. Okay, let me write minus 6. Good. Other thing that we can do, you can let, now just let what? You can just let this x equal to what? Equal to 0. I mean, we'll get a parabola. Even when you do this for y, you get a parabola. What I'm trying to say is this: when it's x is equal to 0, we get this minus 6, or when y is equal to 0, we got this y. So basically, you already know it will be like this. Let me try this, and around here this one. I'm good at drawing. I wasn't expecting this. And around here we've got a bunch of what? Of cycles. Yeah. Ooh, it's beautiful, right? I'm starting to like this. Okay, it's around something like this, right? Something like this. And of course it will go until 12. 12 will be the plane here. So it what I've just done. Okay, I'll do this. 12 is around here, right? It's around here. So what we get, this, it's this. Yeah, I don't know. Yeah, it's good. It's good. Yeah, we've taken so much time just to draw this, but there's no problem. We've got our paraboloid, and the plane here is equals to 12. And after this, what we can do, we can conclude that this integral is equal to what? As we see, first, if we integrate first in respect to z and then y and x, what we get, z, it will be from what? From the parabola. If you do this, from the parabola to the plane, what? To the plane, the parabola here, it's going to be 2x square plus 2y square minus 6 until 0, right? Because you're going to do this. You're going to do this. Okay, wait. Okay. You got this. Then we need to write the shadow, something like that. It's y and x. Let's suppose that you are going to look from the top, here from the top. You're going to see a cycle here. It's a cycle. I don't see it. There's no problem. Just let this x here equal to 12. So if you let this x equal to it's not x, it's set a. I mean, sorry for that. So let's do this. Equal to 12. You get 12. It's equal to this plus minus 6. So if you do some operations here, you got this. It's 18, right? And then it's dividing by 2. We got this. It's 9, right? Okay. Now we can. Yeah, no. Yeah, it's not beautiful. But let's leave it. Minus 3, 3, 3. First, we are going to integrate in respect to y. Y it's going to be like this. So here you see that it's y, it's equal to minus square root of 9 minus this, and here you get it's this part here, that's the positive one. It's 9 minus square root a. No, it's positive. I mean, sorry for this. And of course, x is going to be from where? Hey, sorry, from minus 3 to 3. So yeah, now we can do this. Write this one. It's minus 9 minus x here square 9 minus x square minus 3 to 3. Good. Here we have got it's z over square root of x square plus y square. Good. Now we are going to change. Hey, man, what a video that I'm going to do. But from now on it's easy because you are going to use its change of variables. It's cylindrical coordinates, something like that. Yeah, I'm going to use that. So I hope you know, because it says that it's r cosine of what? Of theta. Y it's r sine of theta, and of course r it's ray, it's ray. Z it's equal to z, and what we get, dv it's equal to r. This is the Jacobian. You can do the Jacobian and you get this answer, right? Then the theta dz, right? So we can come back to this integral. Wait, no, this I can't do it like this. Okay. Bang. Okay. Hey, nope. I guess I need a new page. But no, there's no problem. And of course, here, what do we get? By replacing with this and this, we get its ray r, in this case r. Do you what? We can first integrate in respect to z, then it's we can say dr, then d theta. Yeah, most of the times we integrate like this. Most of the times, nice. Just saying this because yeah, I've got experience, guys. So you need to respect my experience. Good. Yeah, it's still 12, and I said that let's go back here. Good. Yeah, it's one of the limit integration. So just replacing, do the same thing. We need to replace x by r cosine of theta, cosine theta there. If you replace, you get what? It's 2r squared minus 6 minus 6, okay, minus 6, and here there's no need, there's no need. You can't replace, because what are you going to do right now? It's what you see that it's you are going to still use this r. You are going to use r goes from 0 to 3, and the theta is 0 to pi, 2 pi, I mean 2 pi. Yeah. We see something really cool. We can cancel out this and this. Yeah, this integral, it's already solved. There's no need for me to do this. Look at this, it's pretty obvious. Integrating this, it's z in respect to with respect, I mean, to z. Man, I don't know why I'm doing this. I don't know why I'm doing this. It's 12 minus 6 the theta. So what I get here, guys, I see that this video is, it's 12 minutes. No, 12 minutes. So yeah, what do you get? I'm going to put the answer here. You get what? Okay, you'll get, it's doing every operations here, you're going to get minus, no, you can do this. Okay, let's erase this. You'll get is minus 2r to the power 4 plus 12 is plus this dr d theta. Good. And then you're going to get, it's 2 pi here. It's what? Minus 2 this at 5. Get it's 4 and then you got this 3. Okay, here you're going to get it's 864 over 5, and these I won't solve. I can't solve these things, guys. I can't solve this, and this is the answer for me. If you think this is the right answer, okay. So guys, take care and bye bye.